you need to put these numbers somehow into perspective. Now, if you look again at the regular usage pattern of a Death Star, you can assume, well, it attacks roughly 20 rebel bases per year and it has a operational lifetime of 25 years. At least the lifetime is pretty close to a larger medical system you may be familiar with. Well, the rest is more up to your fantasy. So that means it should, well, it runs about 500 attacks during the lifespan of the Death Star. And that kind of means, well, if you have a probability higher than 0.2, if you just divide this 100%, you're sure it's going to happen once during the lifetime of a Death Star. And that's something to be clear about. It's not how bad it is, if we like it, if this happens or not, it's just what's the probability. So that means whatever hazardous situation and harms are there in this situation, if the probability of this thing happening is higher than 0.2, we rate it with a 10 on a scale of 1 to 10. Now, funny thing is, well, these ratings are usually not linear, so that's why you're not just taking the numbers and do some formula. So it also has a certain what can I say, interpretation in it. So in this example, we say, okay, if it's 0.1, so kind of every second Death Star is going to encounter it, we rate it with 8. If it's 0.01, it's a 6, and if it's below 1/10,000th of a percent, then it's a rating of 1, meaning very, very unlikely. It means you would need a few hundred Death Stars exposing to this specific risk to have it happen once. Now we also need a rating system for the severity. So you may know the Likert scales, which gives you a kind of verbal description of a scale from 1 to 5 or 1 to 7, from harmless to catastrophic. Something similar we also use here in this risk assessment or in the risk estimation right now. Again, you need to anchor your rating in some relevant aspect. Now here we just take the percentage of crew being incapacitated. So let's say if more than 20% of the crew is hurt, then it's terrible disaster. Death Star cannot operate anymore. The whole infirmary is collapsing, and people are just busy treating the wounded and cannot do anything else. So everything bigger than 20% of the crew incapacitated is a 10. Then we go down again. You see it's even 0.5%, which is not the big amount of the crew, but still very bad thing, is rated with a 5 and not with a point whatever if you would apply a linear scale. So of course this severity rating heavily depends on the device or the component you are rating. So if you just rate a single turbo laser, well, then the rating is of course a different one, but we're looking at this when we talk about risk cascade and dependencies there. So right now it's just Death Star, this rating. So now we're one step further. We have the probability, you remember, 30%, and we have the severity. Here we just base on some, well, estimation just based on the highest fortified planet we know. That's kind of the planet Swisstopia in the Alpia system. So if we look at this, well, we know that these defensive systems are capable of, well, kind of hitting something between 1 and 5% of the crew before they're disabled. So that gives us now our rating. So we have the probability 30%, that's of course a clear 10, it's far beyond the 0.2 we are aiming at. And we have the severity of a 6. And yeah, I think that's now quite a long video for today. Next time we talk about the risk evaluation.